To solve polynomial equations, we depend on what's called the zero product property, and that's in your notes. Meaning that if I'm multiplying any two values together and the answer is 0, that means that one of the two values has to be 0. And that's what's true when we're solving these particular types of equations. Please make sure that you read all of the steps as far as solving these equations so that you understand, because the most important thing is that the equations are set equal to 0. If they are not set equal to 0, you will have to rearrange them so that they become set equal to 0. So let's take a look at the first problem here. 2c minus 1 times c plus 4 quantity squared equals 0. So what that means because these three are multiplied together and they equal 0, that means at least one of them is equal to 0. So what we do is say, okay, well, if 2c minus 1 is equal to 0, that means 2c is equal to 1, so c is equal to a half. Or c plus 4 is equal to 0. That means c is equal to negative 4. Or c plus 4 is equal to 0, so c is equal to negative 4. Mrs. Busselmeyer, you did the same thing twice. Yes, I did, because it shows up here. The fact that we've got c equal to negative 4 twice is what we call a double root. The solution to this is c equals 1/2, or negative 4 double root, and I just write dr for double root. If you neglect this double root, your answer is not correct. You have to write down that it is a double root. Take a look at the next one. We have x minus 2 squared, and then here, that's a difference of squares. Remember when I told you you had to know how to factor? This is why. So our difference of squares is x minus 3, x plus 3. So one of these four would then have to be equal to 0. So these are the four solutions. You've got a double root here, but notice 3 and negative 3, that's not a double root. So your solutions, negative 3, 3, 2 double root. And I would prefer to see all of these values from smallest to largest with all your double roots listed at the end. So here's our next one. Notice that it's breaking the first rule. It is not set equal to 0. So in order to make this equal to 0, we simply subtract 18 from both sides. And we end up with y squared plus 7y minus 18 is equal to 0. From here, you have to factor. We've got a quadratic, so we factor that quadratic and make sure it's still equal to 0. So remember those rules of factoring. This minus sign tells me that I've got a plus and a minus in these two. The plus sign here tells me that this value will be larger than this value. So two numbers that multiply to 18 would be like, say, 9 and 2, and positive 9, negative 2 equals 7. So just like before, either y plus 9 will be equal to 0, or y minus 2 will be equal to 0. So there are your solutions. Here's another one. Now maybe your first inclination is to subtract 3r from both sides. I don't like to do that. I want the coefficient on my quadratic term, the term that's squared, to be positive. So what I do is I subtract 10r from both sides, and I subtract 8 from both sides. So that becomes 3r squared minus 10r minus 8. Again, it's quadratic. (3r) and r. This means I've got a positive and a negative. I don't know where they go, so I just sort of put them where I think they might go and see if I can figure it out from there. And then I start choosing factors of 8. So I might try, we'll make that up. So 4 and 2. If I multiply these, 3r times 2 is 6r minus 4r. That's not negative 10r. So I'll erase. What if I switched them around? What if I made this a 4 and that a 2? Well, that's 12r minus 2 is negative 10r. That's getting closer. What if I make that a plus and this a minus? That'd be negative 12r plus 2r. That's my negative 10r. So that's how I will work through something like this. Let me clean it up. So I know that 3r plus 2 has to equal 0. Or r minus 4 has to equal 0. So my solutions, negative 2/3 and 4. All right, so we actually did this problem by hand, and we know that we've got roots that are 2, which is a double root, negative 3, and positive 3. So the question is, what does this look like if I graph it? So in order to graph these, go to the y equals in your calculator. And you'll actually just enter exactly what you see is equal to 0. So x minus 2 squared times x squared minus 9. And as long as your window is set to a standard viewing window, you can graph it. And so we've got this sort of thing happening. And we already know what the solutions are, but we can find them by going to second trace. And what I'm looking for is a 0. So I'll select number 2. I'm going to start with this one over here. Okay, it asks for left boundary, so I need my cursor to be to the left of that 0. So here's a value to the left. I know it's to the left because y is 31.95. If I move to the right, it moves down here. So somewhere to the left and hit enter. And then if I move to the right, I hit enter again. You can make a guess if you need to. Probably won't be too easy with this. Hit enter, and I see that I've got a 0 at negative 3. I can do this 0 on the other side the same way. Some left boundary, you actually can just hit enter. You got to move to the right of that 0. I'm looking at my y values here. See how they're getting larger? Now they're where I can see them. So I am to the right of this last 0, which should be 3. Then it asks me to make a guess, so I might just move it to right there as my guess and hit enter, and that 0 is at 3. Now I'm going to zoom in a little bit. I'm actually going to do what's called a zoom box, which means I'm going to draw a box around what I want to see a little bit closer. Hit enter, and then you draw a box. That was our 0 at 2. That was our double root. So we can second trace, look for the 0, something to the left, enter, something to the right, enter, and enter again. Ah, it says no sign change. Interesting. Okay, so that's actually a glitch in the graph. But what I want you to notice is that at this double root, it just touches the x-axis. Whereas if you looked at the root at 3, let me zoom out just a little bit. The root at 3 actually crosses the x-axis. A double root just bounces. Now we get to do word problems. There are 3 different word problems here, and I am going to tell you now so that you can't say you didn't know. On a test, if you see problems like this and you guess and check, I will mark it wrong, because remember that I'm assessing your ability to interpret a word problem and solve mathematically, not guess and check. So with that being said, let's take a look at the first one. 2 numbers differ by 5 and have a product of 84. Find those 2 numbers. All right, so in order to set this up, I need to identify my numbers. My first number would be x. The second number would be some number that's 5 away from x, so x plus 5. So then, and the other thing that I know is if I multiply these 2 numbers, so x times x plus 5, I'll get 84 as my answer. So what I have to do is expand this. And then remember, I want it set equal to 0. So now I have to factor. That minus 84 tells me I have a plus and a minus. Factors of 84 I would think of are 12 and 7. If 12 is the larger number and 7 is the negative, then they will add up to equal 5. So this means that x plus 12 has to equal 0, or x minus 7 has to equal 0. So x can be negative 12, or x can be positive 7. That's the first number. If x is negative 12, then the other number, that second number, x plus 5, has to be negative 7. If x is 7, then x plus 5 has to be 12. So these are the numbers. All right, so next one. The sum of 2 numbers is 9. The sum of their squares is 101. So we start with, my first number is x. My second has to be 9 minus x, because if I add them together, I get 9 as my answer. The sum of their squares is here. So then I expand. Combine like terms and bring the 101 over. From here I can factor out a 2. And then I can factor the quadratic. Factors of 10, I would say 10 and 1. If the 10 is negative and the 1 is positive, they'll add to negative 9. So x can either be negative 1 or positive 10. That means my 2 numbers are -1 and 10, or 10 and -1. So really, I only have one set of numbers. Last one is a rectangle problem. There's length, there's width, and it says the length is 1 meter less than twice the width. So you double the width and you subtract 1. We have an area. Remember, area is length times width. So if I say width times 2w minus 1 equals 55, I have to find the perimeter. That's not a problem. And then to factor, I know I have 2w and w. I know that I have a minus and a plus. And so let's see, if I make this factors of 55, that would be 5 and 11. So 2w times 5, that's 10w. Negative 11 times w, that's negative 11w. So that would add up to equal -1. So now I solve for w. You're not allowed to have a negative width, so you can't use that one. Your width here is 11/2. Your length, then, so 2 times 11/2 minus 1. 2 times 11/2 is 11. 11 minus 1 is 10. So the length here is 10. So now if I need the perimeter, I have 2 times 11/2 plus 2 times 10. That's 20 plus 11. So my perimeter in this case is 31 meters. These are all word problems, so you will have to write out a complete sentence. The only reason I didn't is because I didn't really have space on this particular slide.